I have an announcement regarding those people that are interested in raising heritage chickens. A year ago, a fellow from North Carolina makes his living as a chicken judge. Okay? Can you imagine dedicating your life to judging chickens? But the guy's really, really into it. And he's from North Carolina, and he came a year ago out to Kahua Ranch and did a one-day workshop. And I attended at the last minute, and I was really happy that I did. And he's basically, his concept is that these mass rearing hatcheries where Hawaii people get their chickens, they don't really care about the genetics. They're just interested in, they call them Rhode Island Red or whatever, but they don't care about the genetics, and they're just into selling large volumes of chicks. So his whole dream is to bring back the old American heritage birds. And there's several, in fact, all of the old heritage birds are dual purpose, both egg and meat. It takes longer to grow these out, a little bit more than twice as long as currently is done for most meat birds. And there's some Buckeyes, and there's a few other breeds that may make sense for Hawaii. But if anyone is interested in raising or thinking of raising heritage birds, I strongly recommend going to this seminar. And it's the kind of the beginning one, if you're not really familiar with chickens, I think you might want to, is on Saturday, the March 29th. And the pre-registration fee, I'm trying to look here, is $49. Okay. But you'll learn all about what to look for in a good chicken. You'll figure out if they're laying. They'll talk about how to grow them and everything you want to know about chickens from the basics. On the day before, and I think it's $89 on pre-registration, is for those who are already into chickens and want an advanced course on poultry breeding. And so his website is www.sustainablepoultrynetwork.com. www.sustainablepoultrynetwork.com. And in this, you'll see his, just go to workshops and seminars, and you can read all about this. The deal is, though, he's coming from North Carolina, and a ticket from North Carolina to Kona is over $1,000. And he doesn't have enough people signed up yet to pay for his plane ticket here. So if you're thinking of registering, I would do it in the next couple of days. In fact, if anyone here in the room is interested, raise your hand, and I'll call Jim in the morning and say, so 1, 2, 3.
Probably advanced.
And then 2 advanced. Okay, 3 advanced. Give them
Where is it?
It's in Kahua Ranch, which is on the road from Waimea to Hawaii. It's out about, there's a map right on this website. It's, I'm just trying to think. It's on Highway 250. It's from Waimea. It's about 10 miles out of Waimea, headed towards Hawaii on the old traditional road up on the hill. Well, I found it extremely worthwhile. I'm still excited a year later. And probably will go to his advanced class. And the hope is that if we get enough people here that are kind of like take the class and go, you know what, we like this. We can solve the big issue for us is feed costs, how to get that down. If we can solve that and work together, we could actually develop a big island breed and work together, market together, sell our meat birds, keep our egg birds, and get a branded big island, you know, recognizable, marketable chicken. That's the goal 3-5 years from now. But it's going to take 4 or 5 of us kind of serious about it going and working together to just try to get enough knowledge to be able to get to that next step. So www.sustainablepoultrynetwork.com and sign up if you intend to go, because if he doesn't get enough signups probably in the next 3 or 4 days, he may not make it. Anyway, thanks.
Anybody else have any announcements? There's gonna be some natural farming classes coming up, and I have this poster right here. It's Korean Natural Farming Class Series, Learning to Plant and Grow Organic Sustainable Garden. And it starts March 20th, and then it looks like it's every, like March 20th to 27th, April 3rd to 10th, so it's like every once a week type thing on here. And they're gonna go over making IMO the first 4 weeks, then fermented plant juice, then lactic acid bacteria, egg yolk oil, water-soluble calcium, liquid IMO, and the plant phases. So they're pretty much gonna go over most of the basic inputs for natural farming. This is going to be taught by Jackie Farrell, who's a pretty experienced natural farmer, and also part of the classes are going to take place up at their farm in Kopaico too. So a good opportunity to learn. If you want this flyer here, you can come look at it. This is the only one I have. It's a pretty heavy, nice paper. And so I'll probably also email this out in the next week, or hopefully sooner than that, because it's March 20th, so hopefully the next day too. But good opportunity coming up there.
Is there a cost to the?
Oh yeah, so the cost is $50 for the full series, or $10 a class.
Wow.
So super affordable. Also says seating's limited, so RSVP, and if you anyone want our phone number?
Yeah.
It's 938-5864.
Is that on the website?
It's not right now, but
This is not for certification.
no, you do. I think you get a certificate of completion for doing it, but it's not certification in the input.
In making it.
Yeah. No.
Who would answer the phone? Who are we asking for?
Jackie.
Jackie, that would be Jackie.
It's 4 weeks, right?
It's from March 20th to May 22nd, but with a bunch of gaps in there. I'm sure it fits to some calendar, like every Tuesday or something, but I don't know a calendar to figure that out right now.
What's the first date again?
The first date is on March 20th. Next one's on the 27th, so it seems like it's every week, whatever day that is.
That is a Thursday.
And I'm pretty sure it's going to be at like 6 o'clock in the evening. It doesn't say on here, but I'm pretty sure that's the case, because that's what exactly the same. So it's going to be in the evening. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes in total. So it goes from March till May.
Any word on those classes that University of Nations?
So the co-op, yeah, that's the next thing. The co-op has moved their workshop at the University of Nations. They ended up, it was too much to get together all at the last minute, and they moved it It's gonna be in April, I think, wait. I know I put it on here somewhere. Okay, April 21st through the 25th.
Do you have a number for that?
Not at the present moment. Okay, any other announcements? Does anyone have anything they're trying to sell, like eggs? Like any?
I bought some green papayas if anybody wants them. Just the ones I use to make the salad. But they have to be used green, they don't ripen well. They have like no flavor when they're ripe. But they're really good for cooking. So there's a bucket there. And I love some avocados.
We have organic, non-GMO pork sausage that you're making, like breakfast sausages. We're selling it in rounds, just a 1 pound round thing, so you can slice it and fry it up for breakfast. That's out of our farm, so if anybody's interested in non-GMO organic pork raised, green natural farms, and ground organic herbs, put in phone number. Phone number, make the sausage yourself.
Phone number.
Phone number? We didn't bring it. Its phone number is 965. Yeah. 8235.
8235. And it's like, how much is it?
$8 a pound.
Okay, thank you. That sounds good.
I have some cakes that I just weaned off. I have 5 of them. 1 female, 4 males. They're just weaned off. All raised natural farming, so they're healthy and good. So I sell those 125 each, so if you're interested, let me know. Or if you know anyone who wants really good cakes. Okay, in terms of like, what? I have 5 for sale. So just in terms of what's been happening with CGNF Hawaii, the kind of group organizing natural farming, is we just passed our budget for this year, and so we're getting that together, and we're looking to perhaps expand membership or also do more fundraisers this year to kind of get a little bit more activity happening through there. So we'll probably be offering like membership and benefits for being a member. So right now it's just kind of like up in the air and like sort of free what we do. But to formalize that, to help us organize better so we can provide better support for you, we're working on that to get that out. And good news, after I don't know how many years, we finally may have a nonprofit in like less than a week. Hopefully. If he doesn't get a call back, we're all good. So. Okay. So, any other comments before I go? I'm going to talk a little bit about IMOs and things like that.
I got 2 things.
Yep.
Hey guys, I'm James. A lot of new faces in the room. I haven't been around in a little while. I'm working on several projects for natural farming for Hawaii Community College. We recently finished our movie. We've been working on this for a year. It's literally 2 hours of my ugly mug explaining everything one should probably need to know to start off natural farming and a little bit of the science behind it. Got several professors and interviews. I just got the final copy today. Okay, I got 2 final copies before this, but they were really badly edited. So I made some changes, and hopefully this is the last copy. And if that's the case, then Office of Continuing Education and Training has to figure out what we're going to do with it. We're probably going to offer it as a class and a download online where you basically pay for membership of the class, probably just a couple bucks. And then you get to download HD version, and then you could get possibility of a DVD, and then also informational packet that comes with it with a little bit of definitions that you may not understand that's in the film, and a lot about the practices, and then any write-ups that we have from all over the world, as much as information as we could possibly give out in one packet. So that's coming out soon. We filmed it all over the place. We filmed it at Drake's place. We filmed it with Mike DuPont and guys over at King's Farm. And so,
What's the name of the show?
the movie's called Natural Farming: An Alternative Approach. It's really preachy. That's my fault. They probably shouldn't have had somebody so involved in the movement, star, direct, write, and produce the film. But it also does have a lot of call to action for the scientific community. And that's kind of where I've been standing for like the last 2 years, is trying to get the science and the professors and the universities to accept this as an alternative approach. So that's available. And then I left flyers for a new round of classes that we have through the office, which is an agriculture series. The more you know, the more you grow. It's basically a little bit of the science behind soils, plants, plant nutrition, and microorganisms, some on entomology and nematology. And it's really just for the folks that are kind of turned off or scared of the whole science thing. I'm going to be teaching it, and I'm going to break it down for everybody. And it's a great opportunity to get some wonderful knowledge that you would get maybe at the college level, but you know, brought down to the farmers and the gardeners so that they can fully understand the concept. So we talk a lot about microorganisms, which plays a lot, you know, what you guys do here. So I have flyers over there if you're interested. $39 per class, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 total classes. And that's it. And we have plenty more. We have natural farming classes coming out soon, and then we have business plan development and a bunch of other stuff. But if you're interested, go ahead and grab me at the end.
What's your name?
I'm James. James Rushing.
Oh, I didn't recognize you, James.
Sorry.
I have something to share. I was in Kona, and I haven't been to Kona for like 5 years, and I have a farm in Kubiki, small little farm. And I talked to some, it's the talk of the town, or did I read this in the newspaper that the farmers are, Kona farmers, coffee farmers are being affected by the board beetle. Was it in the paper that said the natural farming techniques are helping him? Was that, did anybody read that? Or something about the natural farming methods of saving the and then I'm walking right in front of Uncle Billy's. This guy has free coffee, and I was told him about the story about, he's like, yeah, but my coffee farm is really having a hard time with the borer beetle. It's going to cause change on the whole coffee industry, you know. It's like, my coffee's going to be more expensive now. And I told him about the natural farming method. He goes, I know the natural farming method. I haven't used it. You know, it's costing me $300 a week. And I could save that if I got to use the natural farming method. So it's like, you're making me want to do natural farming again.
Yeah, it works. Wow. Anything else? So I wanted to talk about the microorganisms, and specifically like IMO, and we chose IMO because a lot of people have been asking questions and things, and kind of wanted to summarize some of the reasons for understanding why Master Cho does certain things in the process of cultivating indigenous microorganisms and microorganisms in general. So I made up this presentation. I was intending on making it a little bit better, but then I just ran out of motivation or inspiration, maybe. And this is what I got. So is everyone here familiar with that Master Cho and then his IMOs? Everyone, like, show of hands, everyone's somewhat familiar, okay. So there he is, and that's the guy with some of his IMOs. I think that's like an IMO 3 from the chicken pen. And they're good things. But why are they good things? It's because the IMO goes through this whole process in Master Cho's method. So it goes, when you collect your IMO in your first stage, you're collecting it kind of on cooked rice or some kind of starch. You're collecting everything out in your environment, so all the indigenous microbes that are out there, and they're kind of have the power of infants. So they're these precious little things that you kind of need to take care of, but you've got a really good diversity and collection. Then in his second stage, you're taking what you've collected and mixing it with sugar. The sugar really helps to stabilize the media, and also helps to kind of feed the bacteria. So you get your best bacteria kind of really taking off quickly and quickly going to sleep because of the amount of sugar put in there. And they're equivalent of like toddlers. They're not brand new newborns. They're kind of moving around and wiggling, but they're not really capable of taking care of themselves yet. In his IMO 3 stage, you're adding in mill run plus a lot of nutrients. Like you'd add in fish or fermented plant juice and fish amino acid and these other nutrients and foods into there. And the basic idea is that you're really trying to multiply and spore out the beneficial fungus. So in the 2-step, we were working on the bacteria, now we're starting to work on the beneficial fungus. And this is the really kind of important parts. This is what kind of, these 3 and 4 steps is what sets Cho's microbes apart from other methods.
What do you mean by mill run?
Mill run is a media to, it's the hulls of wheat or rice. So when they make brown rice into white rice, that hull that comes off is ground up, and that's typically what we're using to propagate this.
Any cellulose type material?
I'll go into this further on what and why on that further in this talk. And so once you've multiplied these spores, it's kind of the equivalent of like high school. You've got guys that are capable of being out there and doing things you want to have done in your soil.
Will the spore be the babies of the fungus?
Yeah, it's like eggs, spores, eggs, like the idea of their thing that they go into and they replicate. It's also a very stable form that when they're in a spore form, they can handle higher heats and more pressure, so they're safe. It's like going into an egg. In IMO number 4, you're taking these really good beneficial fungus that you've got, and you're essentially sending them to college, which is training them with soil. So when you start to give them the soil material, they go from just being beneficial fungus to now being, hundreds of generations of working with soil. So they become experts in manipulating the soil in this 4th stage. So the best fungus now becomes the best soil fungus.
Why do you say hundreds of generations?
Because a microbe typically will go through a generation in about 30 minutes. And so if you leave that pile there for 10, 14 days, they've gone through a lot of generations in that time.
Generation is what?
30 minutes. So I don't know what the math is, but it's a fair amount of generation.
And then what do you mean by nutrients? You say mill run nutrients, soil nutrients.
So the nutrients, again, are the things that we feed them, like fermented plant juice and fish amino acids and other things that are put in there in small amounts. And I'll get further into that later. So it's kind of like, we're feeding in soil and nutrients. It's like giving them the medium to work with plus a little snack pack to go and do their thing.
How many years do they live?
There's microbes from Jurassic times, frozen at bottoms of lakes and things.
They never die, they just keep dividing.
Yeah, they're hard to kill. And IMO 5 is this fifth step, which, and I'll explain the difference between 4 and 5 on the next step, but IMO 5 would be to add in compost and a lot of rich things. And essentially what you're doing is you're making really rich foods to make more complex biology in there. Because these foods are kind of lean and mean, and so you're tuning for a specific thing, but when you add in a bunch of compost, it really increases your diversity and richness of what you're getting in there. And I would consider this like a certified natural farmer. Probably one of the most superior people around. So, can everyone read this? Sorry, it's kind of like should have gone with a darker font. So that previous stage was kind of all the steps of how to kind of go through to make it and what's going on. And this is how Master Cho is taking this substance that you have, and now, yeah, it's probably better. You guys are going to fall asleep.
The video is not going to turn out as well. It's just one issue.
Okay.
I can attach the slides to that video.
Oh yeah?
Like just a PDF, yeah, link to him.
Awesome.
If-
Okay, yeah, whatever works.
Okay. So IMO, the way Cho is typically using IMO is after a major soil disturbance. So say you just tilled up your field getting ready to plant. That's a major soil disturbance. So you want to go and apply IMO 4, disperse lightly over the thing. So it just looks like it's coated, like really lightly, like you dusted it all on there. And that turns out to be about 3 pounds per 100 square feet or 500 pounds per acre. It may be more per acre. I just made that number up.
More or less.
Well, I took it off this spreadsheet, which I wasn't really sure. I don't know. Converting between acres and square feet is not my thing. So you had a major soil disturbance, so you harvested a bunch of sweet potatoes, you're going to replant them, or like whatever happened that you had this major soil disturbance. The reason you want to apply it now is because when you had a major soil disturbance, you just killed all your beneficial fungus, or not killed them, but mutilated them. Because there are miles of these strands in the soil, like miles and miles of them. And when you run a shovel through or a plow through it, you've just disrupted all of their systems and cut them in half. And they're going to regrow back, but they're really damaged at this point. So what you want to do is put IMO 4, which is a bunch more spores or eggs out there. So you've destroyed all the ones that are actively living there, so now you got to put a bunch of seeds and spores back into the soil so that they'll start to rehatch. And so when the IMO 4 is applied to the ground, you also then spray this nutrient solution, which is the soil prep solution, which has all those nutrients in it. And that, you put the spores out, then you feed them this nutrient, and that's what wakes them up out of these spores. And that's why IMO is more concentrated, because we're not just putting out active fungus that's already living. Like if I took my compost pile and I put compost out in my garden, that's all active living fungus, and I'm just going to transfer it from here to there. But when I put IMO out, I'm actually putting out a bunch of spores and eggs out. And so it's essential that once you put the spores and eggs out, that then you really help to wake them up. And this nutrient solution, also if you include humic acids in it and seawater to be like salts, It really helps to wake up those spores and to get into your soil and recreate those networks.
Is that the one that has angelica and liquid cinnamon and all that in it?
Yeah, you can include that in there. That's
And
really
then
helpful.
lactobacillus and all that, the egg. That's that stuff you buy at the market, the black IMO juice. Is that what you call it?
Maybe, I'm unfamiliar with that. But the basic concept here is that once you put out all these spores and all these eggs, you put those out once, and then for the next month, every week you come by and water it. And then you're watering it with all this food, and that's causing all those eggs to wake up and start doing their thing and have enough food to start getting into your soil and start penetrating and doing their business and activating them. So you water it on, just enough to get it all moist and wet. IMO 5, what I've really been figuring out here is like fermented compost, and it's actually better to use on your crops while they're growing, whereas IMO 4, it seems to me from what I'm thinking about the spores, is best to put into for soil building. You want to put the eggs out for soil building, and then when you want to feed your plant, you actually want to feed it this rich stuff with all this complex biology, so you want to put an IMO 5 on it. And there's different ideas about when to apply compost, like every 4 nodes on your plant, depending on what plant and things like that. But if you're going to apply a compost, you would use an IMO 5 fermented compost.
That's a liquid.
Yeah, so as opposed to trying to tea these things, like IMO 5 is better as a tea versus 4. So what I'm trying to explain right here is that IMO 4 spores for the soil, IMO 5 like plant food. Is that clear?
And then I just want to clarify that 1.5 gallons, that's the nutrient solution in water. So it's not really 1.5 gallons of nutrient solution. It's the appropriate things in water at the right ratio of what, like?
Yes.
Yeah, so some will be 1 to 500, some will be 1 to 1,000.
Yeah.
Your first number is 13,000, and then the bottom number is 3,200 per acre. Just so you have the right number. If those are your conversions.
Oh, you're saying like they're not?
Yeah, 13,000 pounds per acre, and then 3,200 gallons per acre would be your conversion.
Well, okay, so this number is correct. This one may be wrong.
Oh,
This
I was
number is
going off
correct.
the
That may
first
be
one.
wrong.
I was going off the first one. Okay.
I should probably note which one, they're just not even put ones that are wrong up there. So,
I converted it if you want.
This is really interesting. When I first came to Dr. Joe's class, he taught us how to make this and all that. And it's so neat how you're saying the relationship. Work together, really good, and dry. Awesome. So you're working them both together. Wow. You need them both to make it better, huh?
well, yeah, that would mean the more you have, the better your, results are gonna be.
That's a lot of microorganisms. He was saying if you overfeed, it's no good. It's like you put too much welfare, but it sounds like you want to feed it.
You wanna feed it at the right dilution ratios. So,
Is this room 100 feet long?
no, this is way more than 100 square feet.
Way more.
It's probably like 500.
So you do 500 pounds for this room.
No,
You said 500 pounds per acre.
this isn't an acre.
Oh, okay, so you did, so this is a fourth of this would be 100 square feet? A fourth of this, no?
100 square feet is 10 by 10.
Oh, 100 square feet is 10 by 10.
Is that right?
3 pounds of IMO.
Yeah, so essentially, when you're looking at it, it looks like you just lightly dusted everything. Like it's not like a thick layer, like inches of stuff on the ground. It's like you just lightly dusted it everywhere.
Oh yeah, 3 pounds, not half pound, a fourth pound of coffee is nothing.
Yeah, no, it's not that much.
And then you put the IMOs, how much do you put, how much liquid do you put on everything?
25 gallons per acre. But So now to go further into depth on each 1, 2, 3, and 4 stages on like kind of the scientific understanding of it. When you're collecting IMO 1, you're doing it with like a cooked starch, just to make an easy available starch. And a lot of people ask about substitutions here. And I think you can substitute for it. I've done it off Hilo and stuff. As long as it's cooked, it generates a really good product. You're gonna have a different microbe for each starch that you use, but it seems to me just a cooked starch will work. So like a cassava, taro, and ulu, the rice, those are all good products. I haven't done a lot of side-by-side comparison of this, using this starch to see what I get. But the idea, basic idea is just being that it's a like cooked starch. And again, you're trying to collect the best fungus. I don't know if I've stressed that enough, but basically what we're trying to do is generate beneficial fungus. So you want to collect in an area where there is already the best fungus. And the best fungus tends to hang out like in the forest, under deep leaf litter, in environments where you see it, the white mold, the mycelium, those networks. Not in a compost pile where it's kind of this artificially created environment where you will get mycelium. Like a lot of people ask me that they got a piece of poop that's covered in white mold. They're like, I got IMO, right? Yeah, but did you get the beneficial fungus and the stuff? You know, like you got an IMO, you got an indigenous microorganism living in this thing, but did you get a beneficial fungus that's going to be then beneficial to your plants? Or did you get one that just like decomposes poop? And so you'll get a lot of different white fungus, but you want to look for it in an environment where you know it's present, where you know it's not really that artificially created, where it's been there for a while, it's really established itself. And I also, put your collection container. I was just out in Kohala and they were doing an IMO demonstration where they put the box inside a cage to keep the rats away, which was cool, but it wasn't close enough to the soil to get the microbes to jump across because the cage put, like an inch separation gap, and the microbe's not going to, an inch is like 10 miles to them. They're not going to go 10 miles up to get this rice. So if you do put in a cage, cocoon your collection box in the right, in the leaf litter that has that mycelium on it. If you have a solid lid on it, like a Hala basket with a solid lid, you can actually just put the leaves all over it. It's like almost bury it. You don't want to like cut it off from oxygen, but really cover it. And people, all kinds of people have been talking about this one, about the altitude and like this and that and that and that. It really, just avoid lower altitudes than where you're at. If you gather microbes from higher elevations, they're going to be stronger, more durable. But if you go get one from the top of Mauna Kea, the environment is so much different from your house, I guarantee that it's probably going to be useless to you. So high altitude is good, but only to a certain degree. Like maybe go to the highest forest or something, like.
Before you said don't go higher than 1,000 in your house.
No, it like avoid lower altitudes is the only go and also when I've been talking to Chris, he's been getting better results when he's getting different collection locations. So he's culturing an IMO in a forest above him, or he's culturing it out in his orchards, or he's in a few different areas. And when you go to make your later batches, you just add a scoop from one and add a couple different IMO ones into your batch to get really good diversity. You also want to collect when it's like really dry out or when it's really wet out, to get that diversity, different weather conditions, different altitudes, different locations on your property. And you can always combine those later when you're making the further steps. But the more spots you get from, the better. And this last thing, when I was over at Chris, he was talking about the cedar box, and I had long ago abandoned the cedar box and just used Lapala baskets for my collection container. Way easier for me, but he was talking about how cedar has this super good relationship with this special fungus that, because it's such a dense wood, however it works, it's undigestible by weaker microbes. So the only microbes that can get into your cedar box and start to propagate on your starch inside are these beneficial microbes, which is why you use a cedar box. It's kind of like a filter, keeping the guys that are superior out and only letting the best beneficial fungus up into your starch medium. So I may invest in some cedar wood and build a box, because once you build one, it lasts for like 1,000 years. So maybe, I don't know. IMO might eat it. But, so those are my. Any questions on IMO 1? So with number 2, it's always a really simple thing, right? You just take the stuff, mix it with sugar. It's like the simplest step in the whole process. But understanding a little bit further of why you would add equal parts of sugar into this thing is because each sugar molecule is going to attach to each water molecule, and it just turns out that equal parts is about the same mole weight, molecular weight. I don't know, some chemical way of quantifying that. So thus, any water consumed also has a sugar attached to it. So every water molecule now has a sugar molecule attached to it because you added equal parts in. And so with that much food, with sugar being a food, the beneficial bacteria quickly dominate your solution and will just propagate really fast because there's so much food, so they'll just take it over really fast. But then because there's so much sugar in it, they have no water to drink and they go to sleep. They're just like, man, I'm so thirsty, I'm just going to take a nap. And they do. And when these sleeping microbes are preserved in this mixture, they'll hibernate for a really long time. Way longer than you even possibly need. Like they'll hibernate for years and years and years, but you don't want to keep it around for years and years, so it doesn't really matter. Does that make sense? Why we use equal parts of sugar and brown sugar for this? Because it ties up the water and makes them go to sleep. So number 3 and 4 are the things that have interested me the most recently and kind of researching on this. And scientifically understanding IMO 3. So it's about spore propagation in this stage. And as temperatures rise and then you turn the pile, you're assisting in spore propagation. That's the whole reason you turn the pile. Like why else would you turn it? Sometimes you turn a compost pile to keep your temperature in a certain profile. But in this case, we're turning not only to keep the temperature in a certain profile, but also to mix it up so that we can have it really sporate out and fill it with spores.
By turning it would make it have more spurs, because it don't get killed from too much heat or what, oxygen, like oxygen.
So this point answers that, and I'll get back to you. But when the pile, well, this point answers it too. So when the pile goes above 120, like you got all this beneficial fungus in our pile, and as the temperature rises and goes like 115, 120, that's about the threshold where beneficial fungus will spore. Because beneficial fungus operates in a lower temperature profile, closer to 100 degrees or so. That's where it's like most optimal in terms of its efficiency. So when it starts to get up to 120, it's not as efficient, and it'll just spore out because it's like, oh, it's too hot. I got to go into this reproductive mode, and it'll spore at about 120.
What does efficient mean?
Efficiency means in terms of metabolizing nutrients into life.
At 100 degrees, they do it when it's real hot?
100 degrees, you're 98.6. That's 100 degrees is not that hot.
That's when they reproduce the best.
Beneficial fungus, yes. And as the temperature profile goes up, nastier bacteria and fungus start to replicate at those higher temperatures, things you don't want to grow. So you do want to turn it to reduce the temperature to ensure that the nutrients are still available for your microorganisms that you want to grow. So not only are your guys sporing out, you're also turning it to prevent the other guys from now consuming these nutrients while your beneficial guys are sleeping. You gotta wake them back up so they lower the temperature so they can be like, oh, I gotta eat that food before the other guys eat it, and you grow the guys you don't want. So the pile is cooled as it's turned. It drops about 15 degrees as you turn it, just on average. And the fungus that was on the inside of the pile was really hot. You'll notice if you reach your hand into a pile, it's cool on the outside, it gets hotter and hotter and hotter until you get into like the core where it's the hottest. And so you've taken this temperature profile that got really hot and you've taken it and you've turned it now to the inside to the outside, or however you just mixed it up and kind of homogenized it. And that process had different fungus growing at those different temperature profiles, so when you mix it up and they all spore out, you're getting now this diversity of beneficial fungus that's sporing as it travels from the outside to the inside of the pile as you turn it. So, does that make sense?
Yeah, but some of it could be bad spores, right? Once it propagated when it's really high temp, it ate more food.
Yeah, and the bad guys that are propagated as soon as you turn it and they hit this lower temperature profile, the good guys always win when it's optimal conditions. So when you return the conditions back to optimal, like the temperature was too high so they went to sleep, and you return it to optimal conditions, they're going to breed faster again than the bad guys. So you want to keep optimal conditions, and then your good guys will proliferate much quicker than the bad guys. And again, your good fungus will grow once you restore the lower temperature. You know, you don't let all those bad guys eat the food, you just turn them, and then these guys wake up and they're like, oh, there's more food, it's not as hot, now I can eat more. And they wake back up and they start to go to work. But if you continue with that high temperature, they'll continue to stay and your stuff won't, you're not growing the right guys. And the foods is what really helps them to stimulate and wake up, because they spored out in the middle of this hot pile, but now there's still humic acid or fish fermented plant juice or fish amino acid in the outside that's unconsumed. And so when the temperature drops, there's still plenty of available food, so they wake right back up. It's not like they stay in a spore form because there's no food available to them. They, as soon as you get these beneficial guys out of the hot temperature, they wake up because there's a lot of food in this pile. And so instead of having it like run out and then turn it, you're turning it while it's still fresh. Like, I don't know a good analogy for that, but you're kind of like stoking a fire type thing. I don't know. I'm trying to think of an analogy for that. But there's plenty of food left, so maybe a good example would be like if you had a thing of vinegar and you're adding baking soda into it, and like you add as much baking soda and it reacts and bubbles out like a volcano, but it'll stop when you stop feeding in the baking soda, but there's still more vinegar. So as soon as you add more baking soda, it'll start to re-volcano. I don't know, maybe I lost you with that. More complex, but the idea being there's more food there, so as soon as you wake them back up, they can eat it, and they'll continue to grow. It's not like it's gone. They just went to sleep because the temperature was too high. And so this one I actually have a thing on scientifically improving it. The other ones were on understanding, but this is actually improving IMO3. And one of the keys here in this process in IMO3, from what we're understanding, is we're really trying to propagate beneficial fungus and spores. So knowing we want to propagate really good beneficial fungus, we can use a microscope to determine whether we've done that or not. We have microscopes over here, so if you're doing it at home, come to the meeting and check your stuff out and see the fungus. And we found that by adding wood chips and humic acid that we get from worms have shown under the microscope to significantly improve the dominance of beneficial fungus. It changes the whole temperature profile in the pile. It pushes it out longer, lower temperatures when you add these things. And that's a characteristic of fungal growth. And also when you put it under the microscope, you see tons and tons and tons of spores when you add in humic acid and wood chips.
Any kind of wood chips? I mean, any
Yep,
kind?
and about 10% of your pile could be the wood chips.
So it doesn't have to be broken down wood chips?
No, you want fresh wood chips with tons of lignin in them, like uncomposted even you could use. You're gonna add so much microbes to it.
You said salt water too?
Yeah, I did. Okay. So IMO 4, the kind of, I don't think I'm going to talk about understanding why, but, okay. So in the IMO 4, like in IMO 3, you've built this really good fungus, right? You've propagated, you've added wood chips and humic acid, you've got these tons of spores happening in this pile that you've turned, you've got this really great stuff. Now it's time to educate these great beneficial funguses how to deal with soil, because that's what we want them to do, is build soil structure for us. We want these spores to go out and start to, move air and nutrients into our environment. And so, if you take this really good fungus and you expose them to equal parts of soil, by mass, turns out, that you, it's like sending a ninja to a training gym. Like if you have a training gym, you're going to be better at it. So when you give them the material to train that way, then they know how to use it. And like I was saying, for hundreds of generations, they're going to know how to work with soil. And so you're really teaching them in this last step how to deal with soil. You're not really propagating more fungus. You're just propagating fungus that's going to be tuned better for soil. And again, in this process, the temperature control is really important. Keeping it down under 120, because again, you're going to get that spore action happening, where there's sporing on the inside, and that's really what you want to do is propagate that to concentrate your biology in there. So any questions on it?
What else can you use other than the meal run rice? What else could you possibly use? Anything other than that?
I don't have enough empirical evidence to suggest other things. Yeah.
Would Albizia wood chips, like fine wood chips work?
So people always ask about substitutions for the mill run. I can tell you from my experience is that mill run is the best. So anything else you're going to substitute with, you're going to have a superior result too. It may be cheaper and more economical for you, but in terms of microorganism propagation, the mill run is like untouchable. It's already the best thing. It's like ice cream. You can't make better ice cream.
Really, from there, you're adding, from there, you add compost first, and then you mix it with the dirt? Or from there, you're putting 1 to 10 parts wood chips, and then you...
No, so if you're curious about the process and actually really how to do it, I'd really recommend taking one of these classes. Because really, what
I did it already. I made the IMO with the rice. I got a bag of meal run. I let it ferment. I got it, and I put it in even parts of dirt. And I didn't have that good results, so now I'm learning why. But I'm wondering if before I put it with the dirt, I saw something up there with compost. If I could have mixed it with compost. You said something like that's when you really get it rich. When you mix it with the compost.
It's true.
What kind of compost? Any kind of good compost, like MacNut compost or something, and then I can mix it equal parts dirt?
I'm gonna
Or take a
not
class?
take questions right now for a minute.
Okay, that's not.
So this, like I said, I kind of made this presentation up as I was trying to get this all together here. And so I went through those 1, 2, 3, 4. This was kind of the slides I started with as kind of like what I was going to try to talk about and cover in this presentation here. And so, like again, it's kind of like a recap. Really what we're trying to do is make fungal spores in there. Not like active growth, but actually like the eggs and the spores. And that's why, the reason I'm bringing this up and the reason I'm trying to like put a lot of emphasis on it is this is the differentiating factor between using CHO's IMO or using like an EM or like compost tea or like worm castings or any other microorganism oriented method, is that CHO's IMO is about the spores and about those eggs and about waking it up that way, and that's why it's a concentrate. That's why you only need, what was that, how many per acre?
Well, you had 500.
Yeah, it was more than that though, right?
What, okay, was the number on the right, or what number on the left?
Okay.
If it was the number on the right, the number I always had was 13 to 15,000
Okay.
pounds per acre.
Yeah, so 1,500 pounds per acre.
50,000.
15,000?
Yeah.
1,500 pounds.
Yeah, no, it's 1,500.
It's 320 pounds per quarter acre.
Yeah.
220 pounds per quarter acre. Yeah. So that's 15.
Yeah, it's about 1,500 pounds per acre is what it is. And 15, so with the recommended dose being 1,500 pounds per acre, if you go get a compost recommendation from people, it's going to be up in the 10 to 20 to 30 ton ratio to get the same bang for the buck that you get with the natural farming. And that's why I'm bringing up this spores again, because why is the natural farming thing so much less material than compost? And the reason it's so much less material is because it's the eggs. You don't need all that other stuff to support the growth. You just need the eggs, the spores. So that's pretty much the key of why that works. And 3 and 4 act as like fungal concentrators that heat up turning acts as a concentration function of concentrated spores. And yeah, like other methods, again, they grow active fungus, and that's not necessarily what you really want, especially for building soil structure. If they're already active, you brood them in water or some sort of thing, you brood them in, or you made them in a compost pile, that's significantly different than soil structure, building soil structure. So using the egg method, yeah, I mean, you gotta imagine growing trillions of billions of millions of eggs, there, and that's really what you're getting is the eggs and that. Okay, and so I just have, this is kind of like on a little, separate little tangent here, but how much of this tree came out of the ground?
50%.
50%, anyone else?
Oh, it's equal to the top, is it the bottom?
Well,
Less than 1%.
You mean like how much of it?
the idea is about only 3% of the nutrients and things in this tree came out of the ground. 97% of the tree is actually like carbon and things that came out of the air, like water, air, sunlight, nitrogen. Yeah, it all came out of the air.
Calcium.
So 90, like even though you see this great big tree here and you think, oh man, all that came out of the ground. No, it actually most of the tree came out of the air. And I like to just bring that up because it kind of makes you think differently about the farming and what you need. Like if you're going to carry a bunch of heavy stuff, why carry it when you can just get it out of the air? Because the air is pretty light. And so just when we talk about nutrient accumulation and those types of ideas, that's why I like the natural farming, because it gets a lot of these things out of the air. And what I'm trying to discover more and more is that the nutrients aren't really in the materials themselves. Like when you build a compost, it's not like, we so often think like, oh, I put 10 parts of nitrogen in, so I must be getting out, 10 parts, or like this, you put it in, you get it out, like the materials. But the that I'm really trying to go on here is that the microbes actually grade it in situ and bring it so that even if the nutrients aren't there, they're almost like bringing it out of the air. And I think I might just skip this slide because I don't really know where I was going with that. Okay, so I think this slide brings me back to that, because like I said, I was kind of writing this. So if plants don't really come out of the ground, they come out of the air, then you can also kind of get like meat out of the air was my idea.
And when you say come out of the ground, or that they don't come out of the ground, you mean they don't derive most of their sustenance from the ground?
Yeah, yeah, it's the basic, like that, this is just like I said, like kind of not a complete thing to present here, but yeah, that's the idea, is that most of the stuff's coming out of the air. So if you don't have your meat present, you know, like if you don't have nitrogen present in something, can you get amino acids out of it? Right? That's kind of an interesting question to pose, and I believe the answer is yes. And I'll go back to this previous slide and tackle this bullet here, which by composting a certain way, you can start out with carbohydrates, which is enough to grow bacteria on it. Once you've grown bacteria on your carbohydrates, they produce enzymes. Some of those enzymes facilitate the transformation of atmospheric nitrogen into ground-based nitrogen, N2 to N3. And by using these enzymes, the microbes can actually synthesize amino acids directly out of the air. And so by not having it present in your starting feed material, you can still create plenty of amino acids and proteins, like right out of the air. And the way to do this and the reason I guess I kind of brought this up tonight, I've just been thinking about this for a while, but is that when you take these carbohydrates and you mix in all those fungal spores into it. So 10% of your feed is IMO4, so fungal spores. It makes sense that you could turn that carbohydrate into mushroom, which is almost like meat. It's complex amino acids. Because you have all these eggs, and then you produce little bacteria, they create the enzymes, which then when those fungus wake up from their spores, they immediately have to grow into something, because you started with just a spore, now it has to grow into something. And it's that as it grows into those carbs, it transforms it from being an egg now into being like a whole fungal amino acid valuable thing that you want to then turn into maybe an animal feed. So does that make sense, kind of how IMO can activate things and bring nutrients out of the air? Like there was no, like they weren't there until you put the IMOs and then all your nutrients came out of the air.
Do you see this happening when you try to make animal feed more? Like you probably see it so live when you're doing that. Just seeing the IMO break down stuff and seeing it feeding pigs, and it's amazing, you know?
Yeah.
Wow. Oh, you watch it right before your very eyes. Just watch the air help them break down.
Well, this process that I'm talking about here, it does happen right before your eyes to a certain bit, but where they're creating these complex amino acids, it's actually on the order of about 3 weeks or so. It's a little bit longer process than just quick mycelia blooming. The actual transformation from carbohydrate into like amino acids takes a little bit longer, because those, all those fungal spores, as they wake up, they have to like propagate throughout the entire material.
So you're proposing using a carbohydrate source to produce a feed that is protein rich.
Yes.
By taking a carbohydrate feed, inoculating it with microorganisms, letting them do their thing to that material, and then the nutrition that is left over for your livestock is protein rich.
Yeah, because they're eating the bodies of the microbes versus
I
the
got it.
material started with. Yep.
All right.
Yeah. It's pretty genius, right?
It's not a bad idea.
Yeah.
I'm not sure if this is connected or not, but I mean, animal or just protein generally is nitrogen, right? And the atmosphere is predominantly nitrogen. Not sure if that would relate somehow into this equation you're working on here,
But the microorganisms aren't going to access atmospheric nitrogen when there's a nitrogen source in the carbohydrate, which is pretty high if you're using mill run, rice bran. So there's no, I don't think the microorganisms would chase the atmospheric. They would go for the nitrogen that is in the material, which is perfectly fine because you're offering them a food source to create a protein. And the carbohydrate is more readily available than protein. So it's taking a more readily available material and turning it into something that's harder to acquire.
Yeah, and the key there is that bacteria can grow on carbohydrates really easily, and it's not that best food for a fungus. So you get the bacteria to bloom really fast, they create enzymes. Enzymes are indestructible organic compounds that catalyze a transformation. And so in simple terms, that means it creates something that as soon as a air molecule hits it, it turns from N2, atmospheric nitrogen, immediately into N3 because it hit that enzyme. And so the bacteria are propagating throughout this carbon, just creating these enzymes because it's kind of like a byproduct of them growing. Like that's just what they do. And then when those enzymes are there, that's the transformational thing. It's an enzyme reaction.
But doesn't it happen internally inside the microorganism and not in the enzyme it excretes on the material?
Probably.
It's internal inside the microorganism.
Yeah, most likely.
Inside special structures.
Yeah. And
So
they're
it's a
gonna,
free-living nitrogen
yeah,
fixing
and
microorganism.
so you're going to start off with something that can only eat carbohydrates, then you're going to get something that can eat the things that eat carbohydrates, then you're going to get the thing that can eat the thing that can eat carbohydrates, and the thing that, and as that relationship gets more complex, all of a sudden now you got an amino acid that you need.
Yeah, I understand the dynamics. I just want to make sure that you understand it.
Okay. And I don't know, this point just kind of sits here kind of alone by itself. But solubility is like one of the biggest things we're all working with. Is a mineral soluble at the right time? If it's soluble too early, it washes away. If it's soluble too late, if you needed it, it wasn't available. So solubility at the precise time is best accomplished by the beneficial fungal network that's working directly with the plant. The plant's signaling, hey, I need more of this nutrient via feeding it certain sugars, and then the fungus responds by sending that nutrient back. And so it can solubilize nutrients at the right time. And I'm not really sure how that fits in, but that's somehow one of my premises here that inspired me to write this. So, are there any further questions?
would you get into the water aspect of how the nitrogen in the water in the rain can become available? Like why that happens?
Yeah, that's with enzymes again, I think. I'm not a super good chemist. I got some ideas of how that happens. Recently, you mentioned rain and extra nitrogen. I was rewatching an old video of when Master Cho went down to look at papayas in Kapoho, and they were having this little black spot all over them. And he recommended using wood vinegar to take care of it. But the other thing he was recommending in that thing for the papayas was that every time it rains, if you spray with calcium phosphate, every time it rained, I was watching it and I'm pretty sure that would be like the only thing you would really need to do. And so I'm testing that theory out right now, but basically I think one of the key, like like fungus runs us over here in Hawaii. Like, you get hit by, you know, everything, like all the papayas have fungal problems, like fungus just is nuts here. And one of the reasons I think is because when it rains, there's extra nitrogen as the plant uptake, and it's soluble nitrogen, extra soluble nitrogen, so the plant has to uptake that. And then when it takes that extra nitrogen, it causes it to swell. It makes it easier for bugs and things to then find a crack into it and penetrate as it's swollen. And so to reverse that swellingness, you need to take that nitrogen that's out and move it, transport it in the core of your plant, and let the plant move it around. It's just stuck in the cells, it'll rupture. And calcium phosphate is one of those things that will move the nitrogen from being in the tips to where it needs to go. And so, I don't know how I got on that.
What's a good form of phosphate, like calcium would be lime?
The natural farming recipe for immediately water-soluble calcium phosphate, which is the thing you need to use in this case, because it's water-soluble, is just dissolving charred bones in vinegar. Super simple process, and that has calcium phosphate in it in high concentrations, but the other key to it is that it's water-soluble. And like I said, solubility is the whole trick to this thing. And so if a plant just absorbed a bunch of nitrogen via too much rain, you're going to need to immediately remedy that situation. And so spraying the calcium phosphate, which is water soluble, will immediately fix your problem.
Can you buy bone meal and use 1 to 10 parts vinegar with it if you can't starve bones?
It's already.
No?
No. Yes.
For this spray that you're talking about after rains, what kind of a dilution?
So Master Cho in the thing was saying that typically you dilute 1 to 1,000, right?
Yeah.
Into your recipe. He was saying that he was only altering the recipe to say dilute 1 to 800. 1 to 800. So he was taking this typical 1 to 1,000 and just increasing it a tiny bit, not even doubling it. So he was already talking about spraying, you know, the spray that includes it on there. But in this case, if you don't have, like, I don't want to talk about that because it's too complex, but if you just use just that component and you spray it after it rains, that's the effect that he was going for.
Yeah, right onto the plant though, right? It's not a,
Yeah, this is a foliar application.
foliage.
Yeah.
Organic farmers typically use calcium phosphate for fungus just as an application because of the pH change. So if you spray calcium phosphate, no matter where you get it from, it's going to drop the, no, it increases the pH. No, it's acidic.
No, it's
It's not, yeah, it's increasing.
Yeah, it's acidic, so it increases the, no, it decreases the pH. And the fungus, right, pH being more like 2.3 is calcium phosphate, because it's a lower pH. So it lowers the pH on the outside of the plant. The fungus can't handle the pH change and typically will die off because of the pH on the outside of, temporarily on the outside of the fruit. So organic farmers use calcium phosphate all the time just to do a pH change, and it certainly would have the same effect with the nutrition of the plant and being able to defend against fungi.
Yeah, I would also venture to say that probably it makes it harder to penetrate the cell wall, which is also why you get a decrease in fungus, besides just the pH change. Like, I think it's probably a complex.
Yeah,
like,
it's a nutrition and a pH thing as well. Because if you're adding calcium, increasing the strength of the cell walls and all that. So it's a kind of a double whammy.
Yeah. So I'm pretty stoked on CalPhos. I've been making a lot more and using a lot more of it because I think, again, previously I talked about the soils, especially in Hamakua, and what Dr. Dunick said about how Hamakua soils really tie up phosphorus. And so by adding CalPhos directly into your plant, you're completely bypassing all the soil and just giving it directly to the plant. So you can get all your phosphorus you need right there. And the dilution ratio being the correct amount at 1 to 1,000. And if you want to increase it 1 to 800.
You spray with like an oil, like neem oil or anything, that, do you think that that would stop the absorption if that's sprayed with the Calphos, or would it go right through?
Through water soluble.
I think it would work fine. I don't, yeah.
Yeah,
Because the neem is like a big molecule, whereas this other one's gonna go right in.
okay.
Cool.
Any other questions?
So the
Thanks.
green grass fertilizer, I heard that used, spraying around by the banana plants.
Yes.
Now, is it putting the animals into the ground also as it's doing that?
So there's a question about green grass liquid fertilizer and using it around banana plants and whether it puts the microbes in there or it just feeds the plant.
Yeah, which is it?
And the answer is that in green grass liquid fertilizer, you have an anaerobic microbe living in there, and you're adding that to your thing. But mostly you're not. Those microbes that you're adding are going to be short-lived. As soon as they're in an aerobic environment that you spray them, they're going to be short-lived. And so you're more going for what they've transformed, like the enzymes they've created while they were living, while you were fermenting it. You're getting like the nutrient and enzymes that they've created versus them themselves going out and doing work. Something may feed on their corpses, so you put them out there and something may feed on them, eat them, and that's where you're going to get a benefit, but it's the actions they perform that are transforming your soil versus them going into your soil and doing the transformation. Any other questions, comments?
Awesome.
That's all I have.
The microscopes, is that on the agenda or no?
Yeah, and if anyone wants to use the microscope, check it out. See, some other people brought some soil samples. If you don't have one, check out what's there.
I looked at the one we made with Kim Chang, had this one green one. You showed me all the way across the screen. No cat.
Okay, what do you see, folks? Anyone?